In this video, we're going to specifically use sum and difference formulas to verify identities. There are a lot of different problems that I might do here, but the one I've chosen to do is this one. Verify the identity, the cosine of x plus y times the cosine of x minus y equals cosine squared x minus sine squared y. Note that we have an x and a y in here, the sum of these two, the difference of x and y in this one, and we have an x in our cosine squared expression. The term with the cosine squared in it has an x as the argument. The sine squared has a y as an argument. So it's important to note that those are different variables and how they're used. I'm going to start with the left-hand side here. It looks to me like I could start with either side if I wanted to think about one side being more complicated than the other, right? But I've just learned about sum and difference formulas, and so it kind of makes sense to start with the left-hand side here so that I can practice that, and because it's fresh in my mind. I don't know, you could argue that the right-hand side's a bit more complex. Let's rewrite. Well, first of all, we're going to write left-hand side equals, and then we're going to copy out cosine of x plus y times the cosine of x minus y, because that's how we start proofs. That's how we always start proofs. And then that line is going to be equal to whatever the formula was for the cosine of x plus y times whatever the formula was for the cosine of x minus y. Well, the cosine of x plus y was cosine x cosine y minus sine x sine y. That's a rewrite of this expression, this factor, into a different form using an identity. Then I'm going to multiply that. This is an implied multiplication. I'm going to multiply that by, and the formula for cosine x minus y was cosine x cosine y plus sine x sine y. And now I have some, what do I want to call it? Distribution, right? Foiling, if you will. I have some distribution to do. But first I want to make a note that the way I got from the first step to the second step was with, let's see, we could call it, for example, sum difference identities. Something like that would work. Right? I'm telling you that IDs, and if you want to annotate something for my benefit, you can use IDs. Not everybody would necessarily know that that means identities, but that's okay in this class. I want you to do this piece. I want you to annotate your steps, so I want to make it as easy for you as possible. We're working with sum and difference identities here, so feel free to use IDs instead of the word identities. Now I'm going to distribute, so I'm going to multiply this term by this term, this term by this term, this term by this term, and this term by this term. So my first is cosine x cosine y times cosine x cosine y. That's my first, right? If you're thinking FOIL, I have a term here and a term here in this factor, and then I have a term here and a term here in this factor. Okay, my outside is going to be, they're both positive, so I'm going to have plus cosine x cosine y times sine x sine y, and that's my outside. And then for my inside, I have a negative times a positive, so I'm going to have a negative here, or a minus. Minus, I think I'll go with, well, it doesn't really matter, sine x sine y times cosine x cosine y. And that is my inside. And then my last multiplication is a negative times a positive, so I'm going to have minus sine x sine y times sine x sine y. Now, it may not be, oh, I should make a note that that is my last. So over here, you don't have to do this part. I did this for your benefit, right? First, outside, inside, last. But my step here was achieved by using algebra. All I did was some algebra. Let's put parentheses around those. Right? And you don't have, you can specify, you can say I did distribution of binomials. But I don't, you know this skill from algebra. This is a minus b and a plus b, or a minus b and c plus d. You know how to distribute. This is just algebra. This is a skill you brought with you to this class. So you can tell me that it's distribution if you want, but if you just want to say algebra, anything that's a prerequisite skill, anything you brought with you to this class, if you already know trigonometry, that doesn't count. But if you anything you learned officially, anything you learned before this course, you can just say that that's algebra, that's arithmetic. Okay, so let's take a look at what we've got here. In fact, let me go ahead and erase FOIL now. We don't really need that. So what we've got left is, what we have at this point is cosine x cosine y times itself. I could write that as cosine x cosine y squared. I could write this term as sine x sine y squared. This one's positive and this one's negative. But I'm going to make the observation that cosine x cosine y times sine x sine y and sine x sine y times cosine x cosine y are the same. Multiplication is commutative, so I could take this multiplication and reverse this factor and this factor and get the same thing here. So I'm gonna make that observation and make the observation that they cancel by doing that. I'm gonna put this, wrong pen, wrong tool, put this algebra up here for this line. And then make a note that we used algebra here as well to cancel these two terms. Algebra. Now, what's left is cosine x, cosine y, cosine x, cosine y, minus sine x, sine y, sine x, sine y. And that is equal to cosine squared of x, because I have cosine x times cosine x. And then I also have cosine y times cosine y, so cosine squared of x times the cosine squared of y minus the sine squared of x times the sine squared of y. Now, it's worth mentioning at this point that we have an identity. It's not the identity that we were asked for, but it would be safe to say that we have shown so far that the cosine of x plus y times the cosine of x minus y equals cosine squared x, cosine squared y, minus sine squared x, sine squared y. And that's true. We have shown this identity, but that's not the identity we were given. There's still more work to do here because we're not there yet, okay? So we need to get creative and figure out how else we can play with this to turn this expression into this expression. One thing I've noticed is that I've got a cosine squared of y here that I don't want, right? Don't want that in there. And I have a sine squared of x that I don't want. So if I could find a way to turn either the cosine squared of y into something with sine of y in it, or the sine of x into something with cosine of x, then I might be in pretty good shape. So let's try that. Let's take the cosine squared of x and leave it like it is. That I do want in my final answer. And let's try rewriting the cosine squared of y. What identities do we have that have cosine squared in them? Well, the one that pops into my head is cosine squared of an angle, let's call it y, plus the sine squared of an angle is equal to 1. If I want to replace cosine squared of y with something, then let's solve for that term. In other words, let's get rid of everything else, in this case by subtracting sine squared of y from both sides, and that gives me cosine squared of y equals 1 minus sine squared of y. So this is another identity. It's just that it's the Pythagorean identity in a different form. So you don't really need to write it down, but it's a very handy form of that identity. So I'm going to replace, where am I? This cosine squared of y with 1 minus the sine squared of y. 1 minus the sine squared of y. It would be tempting to do the same thing here, but I'm not going to do that. And I hope that it becomes clear in just a moment why. So I'm just going to rewrite the second term here. So minus sine squared of x, the sine squared of y. I'm also going to have to erase this scratch word, but remember this identity in both this form and in the other form. If you subtract cosine from both sides, you get sine squared equals 1 minus cosine squared. Those are really handy to know. All right, so I'm going to erase that. I need a little bit more room here. Now I'm going to distribute again. I'm going to take this cosine squared of x and distribute it across 1 minus sine squared of y minus sine squared x, sine squared y. And then I'm going to go up here and I'm going to rewrite the cosine squared term minus, and now I'm going to factor out the sine squared of y. And right now, before I factor it out, it looks like I want my final answer to look. But I can't just jump there. I have to actually verify my work here. So when I factor out sine squared of y, I get cosine squared of x. Notice that I factored out a minus sine squared of y. So I factored that minus out already. That leaves me with a positive cosine squared x. And I factored that out, so it leaves me with a positive sine squared y. So plus, sorry, sine squared x, sine squared of x. All right, let me go back and verify or identify what I did here. I used algebra here to get from this step to this step. It was just algebra. That was where I canceled those terms. In this step, I also used algebra. I just rewrote. I rewrote the expression cosine x, cosine x, cosine y is cosine squared, and so on. And then I did more algebra to show that, actually, no, I did not. In this step here, from here to here, I used an identity. So let me erase that, because that is an incorrect statement of how I got to the next step. I used a Pythagorean, come on pen, a Pythagorean identity. Okay, so that's how I did that step. And then I distributed. So this step here, from here to here, was just algebra. And so where am I now? That's how I got to here. How did I get from here to here? I factored. So that's also algebra. And now I'm going to use another identity, because I don't know if you noticed it, but I have cosine squared plus sine squared here, and that is equal to 1. So my next step is going to be to say cosine squared of x, this is equal to, and this is equal to, minus sine squared of y. And I can either write times 1 to show that I know this identity is equal to 1, or I can just say Pythagorean identity, because that explains how I got from having this as a factor in this side to not having it, right? I used the Pythagorean identity. The Pythagorean identity tells us that the sum of those particular squares is equal to 1. So, where am I here? Trying to clean my work up as I go along. And now I'm done, except that I'm not, because for me, I want you to then write equals right-hand side. And that is what tells me I know you accomplished what you set out to do. This was what you were given for the right-hand side, and look, there it is. So now I actually want you to write equals right-hand side. These justifications of each step are also very important. Don't forget to write those. You can abbreviate, you can keep them very simple, but I do want to see them so I know that you know what it was you did. Something I'd like to observe here, let's see, this one was algebra, this one was algebra, this one was algebra, this one was trig, this one was algebra, algebra, trig, and you don't need a justification for it. I can see that this is the same. But of the 1, 2, 3, 4, 5, 6, 7 steps that we took, more than half of them were algebra, not trigonometry. So you're learning trigonometry. We did use some trig, we used quite a bit, but a lot of your skills in this class are algebra. Your algebra needs to be strong. So that's an important thing to keep in mind. When you get to calculus, one of my favorite things to tell my calculus students is calculus is easy. It's the algebra that'll kill you. Another way to put it is to say that calculus is oftentimes where students learn their algebra. You have to, because it's algebraic skills that we use all throughout all of these classes. All right, the last couple of examples in this subsection are about applications, but I think you can read through those and kind of get an idea of how trigonometry is used in those situations or situations like that. So with some luck, and if we have time, we'll probably discuss some of those in class, but we're going to have plenty of time to discuss applications. So I'm not going to take video time to do that just now. So with that said, this is the end of this section. So in 7.3, we'll be looking at another group of formulas that you need to know called the double angle formulas, the half angle formulas, and the reduction formulas.